Hi everyone. We're going to talk quickly here about graphing when we're in vertex form. So what do we know here? We're in vertex form. We have a quadratic. The telltale sign here is that I have a set of parentheses being raised to the second power. That's a good sign that I have a quadratic in vertex form. Well, as I go ahead and try to graph this, I'm going to start by finding the vertex. Well, I know the vertex is actually kind of easy to find in vertex form. What we have to do is we take the opposite of what we see inside the parentheses. There we have a positive 3. That means the x-coordinate of our vertex is -3. The y-coordinate is a little bit easier. We don't have to change anything. We can just use the number we see outside. So our vertex here will be -3, 2. Now our goal is to graph this function. We don't have much, but we do have the starting point. So what we're going to do is we are going to make a table of values. We're going to always plot 5 points. And what we're going to do is we're going to take our vertex, -3, 2, and plug it in right in the middle. From there, we're going to work our way out. We're going to go 1 and 2 units to the left at -4 and -5. And then we're going to go 1 and 2 units to the right. Now we need to plug in some key values here to figure out what other coordinates are on our graph. So we can use whatever we like, but what we're going to do, we are going to take these values, either -5, -4, -2, or -1, and we are going to plug them in for x in the equation. Since we're using negative numbers and we're adding 3 to it, I think it's going to be easier if we work on the bottom half of our table. So I'm going to plug in -2 and -1 to see what the output is. So our function says 2 times, well, instead of x, now I'm going to plug in -2 plus 3 quantity squared plus 2. So we got to follow our order of operations. We end up with 1 times 2 plus 2, or 4. So we know that when x is -2, y is 4, and when x is -4, y is 4. We're using symmetry to fill in our table. I'm going to do the same thing. I'm going to plug in -1. And what we'll end up with here is the quantity 2 squared, or 4. And here we have 10. So not only do we get 10 there, we get the 2 for 1 special. We get to plug in 10 at -5. Now we have 5 points for our graph. That is everything we need. So I'm going to go to my graph and plot those points. -5, 10. -4, 4. -3, 2. And then we go to the other side of that parabola. We are at -2, 4, and -1, 10. There we have our quadratic, 5 points, and we are done. Now that we're done graphing, let's take a look at those key features. We already found that vertex. That's going to be our first step no matter what we do. And the coordinates of that vertex were at -3, 2. Well, because I know that vertex, I know that our vertical axis of symmetry cuts our graph right in half, as you can see here. And that's going to be an x equals line, and that line goes directly through the vertex. It's going to have the same x-coordinate as the vertex. Our y-intercept is not on our graph yet, so we'll have to find it. Whenever we find our y-intercept, we'll have to plug in 0 for x. So I'm just going back to our formula, which is 2, and in this case, I'm going to plug in 0 for x. I'll get 9 times 2 is 18, plus 2 is 20. So our y-intercept here is the point 0, 20. I can see from my graph that it opens upwards, which means that my vertex is a minimum value. I can see that, this is the lowest point of my graph. The domain for all quadratics is infinite. So we go from negative infinity to positive infinity. And our range here is going to be that y is greater than or equal to the y coordinate of my vertex. So I'm gonna show you guys how to graph in standard form in a minute here, but finding these key features will be the same in both cases. Once we have the vertex, it leads to our, let me highlight what I'm talking about. Once we have the vertex, the x coordinate of the vertex becomes my axis of symmetry. The y coordinate of my vertex, let's use a different color, those are a little close. The y coordinate of my vertex directly is related to my range. The fact that I have a minimum value tells me what direction my range goes in. So you can see once I have the vertex, I have quite a bit of information. I guess if I know that if this opens up, I have a minimum. And, domain is basically free here. So if I have my graph and I have my vertex, a lot of these key features take care of themselves. We'll go a little bit quicker through this one, even though it's in a form we don't recognize. So if we haven't seen this before, this is called standard form. You'll notice that we have no parentheses anywhere in our form here. We still do have a squared x, which means that it's still quadratic. So what are we going to do? Well, just like always, we want to start by finding the vertex. And in this case, it's a little bit trickier. To find the x of our vertex, I use this equation, negative b over 2a. You might be asking, what's a, b, and c? Well, those are just the coefficients in standard form. So if I use this quick formula, opposite of b over 2a, in this case, I will get the opposite of positive 4 divided by 2 times negative 1. And by using this negative b over 2a, I found the x coordinate of my vertex. So in order to find the vertex, it's not quite as obvious from my equation, but with this quick negative b over 2a, I now have the x values that I need. Well, what else does that get? Well, from here, our formula is a little different, but the process is very similar. I'm going to plug in 0, 1, 3, and 4. And you'll see that I have nothing on my y values here, so I'll have to plug in 3 values. Just for ease of use, I'm going to start with 2. So that's going to look, let's keep the color coding. It's going to be negative, and I'm going to plug 2 in for x in 2 different places. So I will have negative 4 plus 8 minus 1, which is, let's see, positive 3. That is our vertex point, 2, 3. So we don't have a symmetrical point. But we do have other points that we can use symmetry for. So let's go ahead and fill those in. I think it's going to be easier to plug in 1. As you can see here, 1 is going to be easier to plug in than 3. 1 squared, following our order of operations, is 1. Making it negative, we get negative 1 plus 4 minus 1. That'll get us positive 2. So that is both our value when x equals 1 and when x equals 3. Now I'm getting closer to being done. My last step is going to be plug in either 0 or 4. Well, plugging in 0 is very easy in standard form. because multiplying anything times 0 makes it go away. So now I have my 5 points for my quadratic parabola. So I'm going to plot those points. I'm going to go 2, 3 over 1, 2, up 1, 2, 3. And then I have the point 1, 2 and 3, 2. Our y-intercept is part of our grid. There it is at 0, -1, and its mirror image on the other side of the axis of symmetry is at 4, -1. All right, hang in there, guys. We're almost done. We're going to grab the key features. I'm just going to do some editing here on the fly. We're going to find our key features in standard form, and then you guys will be ready to go. So we found our vertex as part of this process. The vertex is the first thing we should always be finding, and it was the point 2, 3. Well, if I know that's our vertex, I know our axis of symmetry as well. And I know something about our range. Y has something to do with 3. Well, I have my graph sitting there. I know that's going to be less than or equal to. If you guys are working through anything and you want to just take a quick look at the graph, you can always use your y equals screen on your calculator, or just plug it into Desmos just so you can visualize what's going on. I know my domain. That's always going to be nice and easy here whenever we're dealing with quadratics. I can see from my graph that my graph opens down, which means my vertex is a maximum. And all I need is my y-intercept. Well, we already have it. It is 0, -1. So as you work today, I recommend doing 2 things. Finding the vertex first, and either plotting your points by hand or by using your graphing calculator, and then filling in those key features as best you can. Good luck, everybody.